Hello everyone, myself Kashish Nankani. Today I will explain the topic round robin scheduling algorithm from operating systems. Round robin algorithm is a primitive CPU scheduling algorithm where each processor is given a fixed time slice called as the time quantum. Processes are executed in the FIFO order, first in, first out order. The most important concept here is the time quantum. Each process gets CPU for a fixed amount of time. If it finishes within that time, it leaves the system. If not, the remaining part is added back to the queue. The ready queue is maintained in a circular form. Processes are picked by one after execution. If completed, it is removed. If not, it goes to the end of the queue. The cycle continues until the process is completed. So here we will learn this from an example. We have process P1 of whose burst time is 10 ms, P2 whose burst time is 5 ms, and P3 whose time is 8 milliseconds. Or so our time quantum is 4 milliseconds. Each process will get exactly 4 CPU per turn. So um, in the initial execution, P1 execution runs for 4 ms, so the remaining time of it will be 6 ms. Then P2 will come and P1 will go back to the queue. P2 for P2 runs for 4 milliseconds and the remaining time of it will be 1 milliseconds. Then P2 will also get back to the queue. Then P3 it will run for 4 ms and the remaining time of it will be 4 ms. So after one run, all these processes of remaining execution time are placed back in the ready queue in the order P1, P2. P1, P2, P3 will be in the order. So now for the second round, P1, P1 second round will come. Then it will run for 4 milliseconds again, and the remaining time will be now 2 milliseconds. Still, it is incomplete, so it goes back to the queue. Now for the P2 second turn, for 1 ms, remaining 1 and 1. So the process to is complete. We won't take 4 ms for that. If we have only 1 ms left for that, then we will just complete that 1 millisecond of work. Then for the P3 turn, it will run for 4 milliseconds and at most it could run for 4 ms. So the remaining time of this will be 0 ms. So the process 3 is completed, process 2 is completed. Now for the process 1 is incompleted by the 2 milliseconds, so it will run for 2 milliseconds and then the process P1 will be completed. Now the complete Gantt chart of that. So the Gantt chart will tell us what was the exact execution order of the processor. So first it was P1, then P2, then P3, then P1 comes again, then P2. Here P2's um, execution was completed. Then P3, then P3's execution was also completed, but P1's execution was left. So in the end, P1 also executed completely. So the total execution time of our algorithm was our scheduling processes work was 23 milliseconds. Why round robin is fair? Round robin is fair because each process gets equal CPU time. No process can monopolize the CPU. Also, starvation does not occur. That's why it is suitable for time sharing systems. Advantages and disadvantages. It has fairness as we already saw. Good response time, simplicity, and it is predictable. Disadvantages, context switching overhead, time quantum dependency, poor for long processes, no priority. Choosing the optimal time quantum. If the time quantum is very slow, there will be too many context switches. If it is very large, the algorithm behaves like FCFS. So choosing the correct time quantum is important. Like by choosing the correct time quantum, we can say that our algorithm will be efficient, more efficient. So the time quantum should be large enough. The 80% of CPU words are shorter than time quantum, balancing overhead with responsiveness. So that was it from my side. Thank you.